So why would we not likely place a lot of trust into a estimation that is so far outside of the data values that we're given? Well, this leads us to the next definition, which is extrapolation. That is doing exactly such a thing, making predictions using your regression line outside of the range of the data that you have. This is dangerous because although the association may have a linear shape for that range that you're observing, that might not be true over a larger range. Your predictions may be wrong outside of the range of observed x values. And it says, notice that the regression lines all stop at the lowest and highest data points. So if we actually take a look at our regression equation that we made in Excel, notice that this does not keep going. It stops at the lowest data point and it stops at the highest data point. It doesn't have the arrows on each end like a traditional line saying that you can extend this over the entire range. So what this is telling us is that this line is basically only good, it's only reliable between the lowest and the highest data value that we've got, and going below or above it would be called extrapolation, and we shouldn't do it. It's not trustworthy. An influential point is a point whose presence or absence has a large effect on your conclusion. So note, an outlier, which we've heard of before, an outlier may or may not be an influential point. You have to determine whether it's affecting your conclusion drastically or not. So you can have deviations and you can have outliers, and maybe if you delete them and recalculate, not much changes. So that would then be an outlier, but not an influential point. However, then if you have an outlier where if you delete it, it changes everything drastically, and if you put it back in, it changes it back, that one would be considered influential. So in this case, we have crime rates, the number of reported crimes per 100,000 people, versus population density, which is people per square mile, in 2008. Figure A includes all 50 states plus the District of Columbia, and Figure B omits DC. So what we have in Figure A, all of these points over here represent the 50 states, and here's the District of Columbia over here. Notice that the District of Columbia is very, very more densely populated than any of the states, and it also has a very, very high crime rate. The R value, the correlation coefficient calculated with all of this data, is 0.412. I'm not surprised that it's a pretty low correlation, considering this line does not really seem like it's doing a good job predicting all this data, because it has to come out here to include this very big outlier point. At this point, when I'm looking at just this first graph, I'm saying that's definitely an outlier. Now, when we look at what happens when we delete this point and recalculate. So they deleted this point and recalculated. When they recalculated, they were able to stretch these axes out longer and count by something much smaller in increments, because they didn't have to try to get all the way to this very high value. So they stretched it out. So this is what all those points look like magnified, basically. And look what happened. The R value is now negative 0.145. So it still seems like it's a very poor estimation. It's a very weak trend. The population density versus the crime rate don't really seem to be associated very strongly at all. But it took it from a positive association, weak as it may have been, to a negative association, still very weak. So would you classify DC as an outlier? I would, or it's definitely an outlier. Would you classify it as an influential point? I would say yes, because it not only changed the strength, of the correlation by a lot. It even changed the direction. So note, though, this is a very drastic example. Okay, this was sort of the most drastic example that could be easily found. It doesn't have to do something as drastic as change it from a positive trend to a negative trend or vice versa.